So the moment that you drive a new car off of a dealer's lot, the car is worth less than what you paid for it. This phenomena is called depreciation, which means that as time goes on, the car is worth less and less. Some cars depreciate more than others, that is, they depreciate at different rates. But most cars do depreciate over time. On the other hand, some older cars actually increase in value over time. This is called appreciation. Um, Geraldine had a choice between buying a new Concorde, I believe that's a Accord, a Honda Accord for $27,000, a used Escalade or Escalade that would have been, and there's a modification here. This is a typo in the book. This is supposed to be $56,000. So make sure you're using that number. $56,000 if bought new if bought last year, or a 1967 Mustang for $18,150. Consumer Reports reports that the value of the Accord depreciates at 6% per year, and the Escalade will be worth $28,627 3 years from now. It also reports that the appreciation of the Mustang has historically been very consistent and expects the trend to continue. So a piece of information here, if you look at the Ford Mustang, right, if you were to buy this 67 Mustang this year, they're claiming that this car would be $18,150. Last year it would have been $16,500, and the year before that $15,000. So if we look at those three data points and we go with the assertion here that it's been historically very consistent, we might be able to figure out what our multiplier is there and continue that trend. So one of the things we can see here for the Honda Accord is we do have two data points, the 27,000 and then the 25,380. And we are told that the Honda Accord is typically will depreciate at a rate of 6% per year. And if you actually take the 25,380 and divide that by 27,000, you actually see the 6%. Now let's be careful. What I mean by that is if I do the division, right, 25,380 divided by the 0 year, 27,000, you can see I get 0.94. That means my multiplier moving forward is 0.94, which is, we should interpret it as we're retaining 94% of our value, and therefore we're losing 6%. So if something's decreasing by 6% each year, you're retaining 94% and your multiplier is 0.94. So that would help us build an exponential model for that particular car. The other piece of information that we have that was given in the problem was that the Escalade starts out with an initial value of $56,000. And if I'm looking at that, figuring out a model for that's a little bit problematic, because in order to go, I have to apply my multiplier 1, 2, 3 times. So there's some value, right, that I'm multiplying by repeatedly 3 times to get down to 28,672. Now, if we think about this, our model is y equals a times b to the x, our exponential curve. A is our starting value, so in this case we've got y is 56,000 times b, this multiplier we don't know, but if I apply that multiplier 3 times, in other words, multiply by b times b times b, multiply by 3 factors of b, I should get 28,672. And that should be a pretty straightforward equation to solve, right? We need to find our value of b that would produce this depreciation that we see. Clearly the Escalade is something that is depreciating over time. The other car that we have is the Ford Mustang, and we are told that it has historically been very consistent. And when we look at the data that we have, it's actually appreciating for the 3 data points that we have. We have this year that this is a data point that's given, right? We know that this year it's 18,000. But the other thing that we know is what it is the year before and what it is the year before that. So if I think about that using those 2 previous years, I should be able to figure out what the multiplier is, what it's appreciating by. And then I can use that multiplier to complete this table, but also I can use it to write the equation. Once you have the data table completed, right, I would like for you to graph these data points on this graph. The one thing I will caution you about is these numbers on the y-axis are in 1,000s of dollars. So when we're up here at the number 50, that's $50,000, $45,000. And then these numbers along the bottom are years. X values are years. Years from now, whatever now is. C does ask you to write a function for each of the cars. So you can write each of those down here. Also, there's a spot to include those functions in this table, right? So for example, N, you can include the function for the Honda Accord, the Cadillac Escalade, and the Ford Mustang there as well. And then there's just a couple additional questions. If you need assistance, please call me over to your group and I'll be happy to help.